Hello students. Last in the last lecture we have discussed regarding the classification of carbohydrates. So briefly we will discuss the same thing. The classification is done on the basis of number of units. Okay, number of units. So they are classified as monosaccharides. Monosaccharides. Monosaccharides are the carbohydrates which cannot be further hydrolyzed to smaller molecule. That is called as a monosaccharides. Okay, and generally they having 3 to 7 number of carbon atoms, and they have represented by formula CH2ON. Okay, so oligo, second one is oligosaccharides. Oligo means few, and the carbohydrates which on hydrolysis gives 2 to 10 number of monosaccharide units. They are called as a oligosaccharides. Now these oligosaccharides are classified into three categories: disaccharide, saccharides, and tetrasaccharides. Di means two. Okay, so the carbohydrates which on hydrolysis gives two molecule of same or different monosaccharides are called as a disaccharide, and examples are lactose, maltose, sucrose, ampel. They are the example of sucrose, maltose, and lactose. These are the example of disaccharides. Okay, then trisaccharides uh, trisaccharides are the carbohydrates which on hydrolysis gives three molecules of same or different monosaccharides are called as a trisaccharides. Okay, and the example is raffinose, which gives one molecule of glucose, fructose, and a lactose after hydrolysis. Okay, then tetrasaccharides are the carbohydrates which on hydrolysis gives four monosaccharides, four molecules of monosaccharides, and the example is stachyros. So while in the last lecture I have written it as a sandy rose, it is not sandy rose, it is a stachyros. Okay, so which gives a molecule of glucose, fructose, and two molecules of galactose after hydrolysis. Okay, so we will move for the next classification, that is polysaccharides, the carbohydrates which upon hydrolysis gives uh, large number of monosaccharides units. Okay, they are called as polysaccharides. Okay, but general polysaccharides, commonly known polysaccharides are starch, it is a cellulose, glycogen. These are the examples of polysaccharides. Okay, polysaccharides. Now the carbohydrates are classified as a saccharide units, that is monosaccharide, monosaccharide, oligosaccharide, polysaccharide. This is one of the classification. Then second classification is as a sugar and non-sugars. Okay, so what is meant by sugars and non-sugars? So the carbohydrates. Okay, so generally the monosaccharides and disaccharides, they are sweet in taste, and that's why they are called as a sugars. They are called as a sugars, while the polysaccharides, so generally the trisaccharide, tetrasaccharides, and polysaccharides, they are not sweet in taste, and that's why they are called as a non-sugars. They are called as non-sugar. Okay, so this is the idea behind the classification as a sugar and non-sugar. What it is, the carbohydrates which are sweet in taste, they are called as a sugars, and the carbohydrates which are not sweet in taste, they are called as a what, uh, non-sugars. Okay, the next classification of the carbohydrates is done as a, or this sugars are classified as a reducing sugar and non-reducing sugar. or reducing carbohydrates and non-reducing carbohydrates. So what is this? We will discuss. Okay, so those carbohydrates which are capable to reduce Tollens reagent and failing solutions. Okay, carbohydrates which are capable to reduce the Tollens reagent and failing solutions are called as reducing carbohydrates or reducing sugars. While those which do not reduce these reagent, that is Tollens reagent and filling solution, are called as a non-reducing carbohydrates or non-reducing sugars. So all monosaccharides, that is aldose or ketones and disaccharides except sucrose, are reducing sugars or reducing carbohydrates. So all monosaccharides and disaccharides, they are reducing type of sugars except sucrose. Sucrose is not a reducing sugar. So keep in mind that sucrose is an example of what? Non-reducing sugar. Non-reducing sugar. While all polysaccharides, they are non-reducing sugars. Okay, now we will move for the next point. Okay, what is that? The monosaccharide. Now in this unit, what we are dealing with, that is monosaccharide. Okay, so monosaccharide, which is the simplest carbohydrate, which is not hydrolyzed further to simple molecule. It contains 3 to 7 carbon atom, and there are 20 monosaccharides occurs in the nature. Occurs in the nature. Okay, 20 naturally occurring monosaccharides are known. Now these monosaccharides, what we are calling it as, they are classified into two categories based upon the functional group present in the monosaccharides. Based upon what? Functional group present in the monosaccharides. So which are those? The monosaccharides are classified as aldose and ketones. So those monosaccharides which contains aldehyde as a functional group, CHO as a functional group, they are called as aldose. They are called as a aldose. While the monosaccharides which contains keto group, carbonyl group, okay, divalent carbonyl group, they are called as a ketones. They are called as a ketones. Okay, so if we try to classify these aldose and ketones further, then they are classified as a triose, tetrose, pentose, hexose, heptose, depending upon the number of carbon atom, depending upon the number of carbon atom present in the structure. Present in the structure. So they are classified as a triose, tetrose, pentose, hexose, these like this, heptose. Okay, and depending upon number of what? Carbon atom present in the molecule. Okay, so aldose, aldotriose, aldotetrose, aldopentose, aldohexose, aldoheptose, or ketones, they are classified as ketotriose, ketotetrose, ketopentose, ketohexose, ketoheptose, like that. Okay, so let us discuss some example related to this classification. Okay, so first, what we are discussing, the class, then molecular formula, structural formula, and an example. So first we will discuss aldones, aldotriose, aldotetrose, aldopentose, aldohexose. So aldotriose C3H6O3, this is the formula, and the example is glyceraldehyde. Example is glyceraldehyde. Okay, aldotetrose C4H8O4, and the examples are erythrose and threose. aldopentose C5H10O5. Okay, the structural formula, it is written in the table, so you go through that, you will get the structural formula. So what are that? Arbinones, ribose, xylose, lyopsose. These are aldopentose. Aldohexose C6H12O6, which we know all of you. And the examples are glucose, mannose, galactose, and talose. Okay, glucose is there. Okay, these are the example. Then ketotriose, ketotetrose, ketopentose, ketohexose. Okay, so what are these? Ketotriose C3H6O3. Now molecular formula is same, but difference is only of the functional group. Okay, in the aldose there is aldehyde, and in the ketose there is a what? Ketone. Same molecular formula. So the example of triose is ketotriose is dihydroxyacetone. This is an example of ketotriose. Then ketotetrose, the example is erythrulose. Erythrulose is the example of tetrose. Aldopentose, the example is ribulose, cellulose. And ketohexose, what we are going to deal with, that is C6H12O6, fructose, sorbulose, and tag, tactalose. These are the example of ketohexose. Now we will deal with the structure of the what carbohydrates. We will discuss the first open chain structure, and then we will move for the ring structure or cyclic structure. So there are two structures are referred for the carbohydrates or monosaccharides. One is open chain structure, another one is cyclic structure. So we will discuss first open chain structure. So most naturally occurring monosaccharides are pentose and hexose. Okay, keep in mind that naturally occurring carbohydrates are monosaccharides are pentose and hexose. What it means? It means they contains 5 and 6 carbon atom in their molecule. Okay, the aldopentose common aldopentose, so commonly occurring aldopentose are which having aldehyde as functional group. They are D minus ribose and deoxyribose. D minus ribose and 2-deoxyribose. Okay, while glucose and galactose are most common aldohexose. Aldohexose. So aldopentose and aldohexose we are discussing, and commonly occurring aldopentose are ribose and deoxyribose, and aldohexose are glucose and galactose, while fructose is the most common ketohexose. Okay, so ketopentose we are not dealing with that. Most commonly is only fructose, and that is a ketohexose. So in case of open chain structure, whenever we number the chain, okay, whenever we number the chain, we number it from aldehydic carbon atom. The first number is given to aldehyde group, the carbon atom which is a part of aldehyde group, and then the numbering will come down. So in the first structure, what it is, D minus ribose, this one. Okay, the first structure numbering is 1 2 3 4 5 like that. Okay, and the first carbon is what it is, a aldehyde group. In case of 2-deoxyribose, why we are telling it as 2-deoxyribose? Okay, understand the thing. The second structure, this one. At the second position, look at the two structures. the first one and second one. The second carbon, okay, in case of ribose, it consists OH group, okay, but in case of 2-deoxyribose, it do not consist of oxygen, it is just a hydrogen, it is not OH, it is just a hydrogen, okay. Now what is thing, the oxygen is removed, okay, oxygen is absent over there, and that's why what we are saying at second position, D means removed or there is absent, oxy means oxygen, and it is a ribose, no problem, it is what, a ribose. Then look at the next three structure. The next three structure are D minus glucose, D plus glucose, sorry, D plus galactose, and D minus fructose. So the first one is D minus, what it is, D minus glucose, the first one. Numbering is same, 1 2 3 4. It is started from aldehyde carbon, okay. So this is glucose, 6 carbon atom, okay. At the third position there is a change of hydroxy group. Hydroxy group is on left hand side and hydrogen is on right, okay. In case of plus galactose, okay, check out the galactose, what it is, what is there, the carbon number is 6, no problem, there is a chain of 6 carbon atom, but at the position of 3 and 4 the hydroxy groups are on left hand side, okay. Whenever we write two hydroxy groups, carbon number 3 and 4, at the left hand side we will call it as a galactose, and if only the one hydroxy group, that is carbon number 3 hydroxy group, is on left hand side and all other are on right hand side, then it is called as a glucose, okay. Now look at the structure of fructose. The numbering is done 1 2 3 4 from top, this one structure, what I am trying to tell you, okay. The last structure, okay, this one numbering is from one top 1 2 3 4. So how to number the carbonyl group or keto, okay. The numbering is done from that end or that end of the chain which is nearer to so lowest number will get to carbonyl carbon atom, lower number must be to carbonyl carbon atom, like that we are writing the structure of ketone, so numbering of ketone, okay. So 1 2 3 4, at second position there is a carbonyl carbon atom, at first position there is a CH2OH, at bottom there is a CH2OH, third carbon atom. Look at the structure of glucose and fructose, okay. The structure, this structure, and the last structure, the third structure. At the third position there is a hydroxy group on left hand side and all other hydroxy are right hand side, so both are D minus, both are D minus glucose, D minus fructose, like that, okay. So numbering is done from the end which is closest to what, carbonyl carbon atom. Now look at the structure of glyceraldehyde and dihydroxy acetone, which are the triols, aldo triols and keto triols. So aldehyde OH is on right hand side, and that's why what we are writing D plus glyceraldehyde. If we write this center hydroxy group or the second number of this hydroxy on left hand side here, like this, okay, and here it is hydrogen, then it is D minus glyceraldehyde, okay. OH on left, hydrogen on right hand side, like this, okay. Then what it is D minus glyceraldehyde, keep in mind, okay. Now we'll go for the next thing. What it is, why we are writing this capital D before the name, and why it is dextrose. Already what we have written in the definition is that what is carbohydrates are optically active polyhydroxy aldehydes or polyhydroxy ketones. They are called as aldehydes, correct? Sorry, carbohydrates. Now optically active, okay, optically active. While writing this letter D and L, D stands for dextrorotatory and L stands for levorotatory. Now look at the structure of glyceraldehyde, okay, but initially the system was used as D means dextro and L means levo, but we are not using that capital letters. Instead of that capital letters, we used to write small d and small l. Okay, but nowadays the small d and small l is replaced by plus and minus sign. Okay, plus and minus sign. While this d and l, capital D and capital L system, is changed. Okay, what is changes? I will tell you. Look at the structure of glyceraldehyde. Okay, what I am trying to say before few minutes. If OH is on right hand side, then it is called as a plus glyceraldehyde, and if the OH is on left hand side, it is called as a minus D glyceraldehyde. Okay, now this D letter, capital letter D, is referred to configuration of OH group. Okay, configuration of OH group, and penultimate or next to carbon atom of a molecule as derived from glyceraldehyde. Glyceraldehyde. So from the bottom, okay, from the bottom side, so from this side, this one, okay, the second carbon atom, what is the configuration of that second carbon atom? Depending upon that, what we are writing D and L. So look at the last what we are structure we are dealing with. Okay, these structures. So all these structures, look at the carbon atom second from the bottom. Okay, second from the bottom, all they contains, okay, all of these OH, all the OH are on right hand side, and that's why we are writing D. That's why we are writing it as a D. Okay, and if the carbon hydroxy group is on left hand side from the second position from the bottom of the structure, so if it is matching with glyceraldehyde, then what we say it as L. Okay, so here it is this one. Okay, if OH at the second position is from the bottom, okay, consider from bottom. Okay, next to aldehyde it is actually in case of glyceraldehyde, but while discussing pentose and hexose, it will changes the position. So it is fifth carbon atom in case of hexose, and in case of pentose it is fourth carbon atom. So we have to deal with that. Okay, now minus and plus signs. Minus means what I am saying, optical activity. What we are discussing, optical activities. The signs represent the optical activity of structures. Okay, so optical activity, if we consider, when we write plus, it means that it is dextrorotatory. It is going to rotate the plane of plane polarized light towards the right hand side, and whenever we write minus, it means that the structure or the substance is going to rotate the plane of plane polarized light towards the left hand side. Okay, so this is regarding the what open structure. Now we will discuss the what uh, closed chain structure, cyclic structure, okay, of the monosaccharides. So what is that? Okay, so if we react this aldones and ketones with alcohol, they gives first hemiacetal or hemiketal, and then they gives acetal and ketal. So this reaction we are discussed in the alcohol, okay, or in the aldehydes and ketones. Okay, reaction of aldehyde and ketone with alcohol. Okay, so we are saying it as esterification reaction, ester formation. Okay, no, not esterification. We have discussed as a aldose and sorry, ketals and acetal, like that only. Okay, so since monosaccharides contains number of hydroxy group and aldehyde or keto group, therefore now both what we have discussed, a simple aldehyde and alcohol, whenever we try to react, they gives hemiacetal and acetal. Reaction is given over here. Look at the general reaction. This is your aldehyde. Okay, this is what aldehyde. So here is a mistake. There is a extra bond they have given. But this is what divalent. Sorry, monovalent actually. So when we try to react this aldehyde with what, with alcohol in this reaction, this gives hemiacetal first. What is hemiacetal? Hemiacetal is the compound in which hydroxy and alkoxy, hydroxy and alkoxy, that is OH and OR, they are present on same carbon atom. Then it is called as a hemiacetal. And if we react this hemiacetal further with alcohol, that OH is replaced by OR. Now the carbon contains two alkoxy group, then it is called as a acetal. Okay, likewise we have written the reaction for ketals. Okay, ketone on reaction with alcohol gives first hemiketal and then ketal, okay, so what it is, alcohol on reaction with aldehyde or aldehydes and ketones on reaction with alcohol gives hemiacetal and hemi hemiacetal, hemiketal of ketal and acetal. Now if we look at the structure of aldopentose, aldohexose, okay, they consist number of hydroxy groups. Okay, and what is hydroxy? If carbon contains hydroxy group, it is alcohol. Okay, now if already hydroxy group is there in the same structure and there is aldehyde and ketone functional group, okay, there is a chance that hydroxy group may react with keto group carbonyl, that is ketone carbonyl or aldehyde carbonyl, to give a cyclic structure. And when this reaction will take place, okay, there is chance that the carbon number second hydroxy group may react with the aldehyde or keto group. Third number carbon may react, the hydroxy of third number carbon may react, fourth number may react, fifth number may react. Okay, the sixth number is not going to react at all. Okay, why? That is primary. Okay, now if we try to write the structure of all these, okay, so from starting from carbon number 2, 3, 4, 5 and 6, what will happen? We will get 3-membered ring, we will get 4-membered ring, we will get 5-membered ring, we will get 6-membered ring. Okay, so oxygen is one of the member of the ring. So if we go for the stability of these structures, Okay, stability of 3-membered ring, 4-membered ring, 5-membered ring, and 6-membered ring. It is it is clear that the 5-membered and 6-membered cyclic structures are more stable than 3-membered and 4-membered. Okay, and that's why there is a chance that the carbon number 5 and carbon number 4 may react to give a 5-membered ring or a 6-membered ring. Okay, so always aldo hexose or aldo pentose, they are going to form a 5-membered or 6-membered cyclic structure, that is acetal or hemi acetal or a hemi ketal. Is it clear? So which are those 5-membered and 6-membered ring which are stable rings which consist of oxygen atom is one of the ring, one of the constituent of the ring. So those two stable structure, we know that one is furan. Okay, what I am saying is that one is furan, another one is what, pyran. Okay, so if a 5-membered ring is formed by reaction of the carbon atom, hydroxy group of fourth carbon atom in case of glucose. Okay, and if it is giving a 5-membered cyclic structure, then it is resembles, it is perfectly matching with this furan, this one. Okay, and if the carbon number 5 hydroxy group is react with aldate group, then it gives a 6-membered ring which is resembles to this pyran. Okay, pyran. So depending upon that, these monosaccharides, they are called as pyranose and furanose. They are called as pyranose and furanose. If we are getting a 6-member hemiacetal or hemiketal, then it is called as a pyranose. Okay, and if we are getting 5-membered hemiacetal or hemiketal, then it is called as a furanose. Okay, so this is regarding the cyclic structure, and we will discuss the cyclic structure of glucose. Okay, cyclic structure of glucose in detail in the next lecture. So thank you, hope you are understanding the concepts. Okay, why I am trying with this screen recorder, or I am not recording on the board, because henceforth what we are going to discuss, okay, it requires more time to write on the board, to draw the structure on the board, and that's why I am directly dealing with the book. Okay, directly dealing with the book, I am discussing on the uh, like ppt or screen recording. Okay, so why I'm doing this screen recording, to decrease the what, uh, writing. Okay, or uh, to reduce the time. Okay, so I will got more time to discuss the structures and the things. Okay, so we will stop over here, and we will discuss the structure of glucose and the fructose in detail in the next lecture. Thank you.